Question 2007, number 4, we have no TI that we are using in this problem. So, I have a position function, part A, find the time at which the particle is furthest to the left. Justify my answer. So, here we go. Let's see here. I would say that the particle moves left when velocity is less than 0 or velocity is negative. If I want to find out when this is happening, then I better find out when velocity is 0 and then set up a number line so I can figure out when is it moving left and right and try to figure out when is it furthest to the left. So to find velocity, I need the derivative of position. So when I take the derivative, I need to do product rule. E to the negative t times cosine of t plus sine t times e to the negative t times negative 1. So I'm just going to rewrite that a little neater. Velocity is equal to e to the negative t cosine t minus e to the negative t sine t, and I want to know when that is equal to 0. So what I'm going to do, I'm going to pull out an e to the negative t. That leaves me with cosine t minus sine t equal to 0. So what I want to do now is figure out when does e to the negative t equal 0? Never. When does cosine t minus sine t equal 0? When cosine t is equal to sine t. Now here's the trick with this question. I do not have a calculator. Therefore, my answer must come from a graph or a triangle. If I look at my cosine graph and my sine graph, well, when are they the same? That's a little interesting. I'll skip that for now. If I look at my triangles, 30, 60, 1, 2, radical 3, and then my 45, 45, 90, 1, 1, radical 2. Here's something. If I look at 45 degrees, cosine is a over h and sine is o over h, which is going to be the same because the o and the a are the same size. So I'm talking 45 degrees. Now, 45 degrees. If I look at my quadrants, sine and cosine are both positive in quadrant 1, and sine and cosine are both negative in quadrant 3. So I'm saying when t is pi over 4, 45 degrees in quadrant 1, and then 5 pi over 4, that's 45 degree reference angle in quadrant 3. Velocity number line, 2 pi, 0, I've got pi over 4, I've got 5 pi over 4. Here we go. So I need to figure out what are my signs, what's happening here. In between 0 and pi over 4, this is 45 degrees. I could use 30 degrees, which is pi over 6. So if I look at 30 degrees, then I would have, let's see here, cosine of 30 is radical 3 over 2 minus sine of 30, which is, let's see here, minus sine, which is 1/2. Radical 3 is 1 point something, so this is going to be a positive number. In between 45 and pi over 4, let's see here, this is 45 degrees and this is what, 225? So maybe I use 90 degrees. Let's use pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so 0 minus 1 would give me a negative number. Okay? And then in between here, let's say 270, which is 3 pi over 2, which is lovely. 3 pi over 2. So cosine of 3 pi over 2 is 0, and minus sine of 3 pi over 2, which is negative 1. So 0 minus negative 1, that's going to give me a positive number. So based on this number line, my function is moving right, left, and then right again. So if I look at this, my particle is doing something where it's going to the right, to the left, and then to the right. I want to know when is it furthest to the left. Well, I need to figure out that could be at 0, or it could be at, let's see here, 5 pi over 4. So this is what I need to figure out. What are the positions at those different times? So if I sub 0 into the original position function, I have e to the negative 0 sine of 0, which is 0. If I sub it in here, I have e to the negative 5 pi over 4 times sine of 5 pi over 4. Well, e to anything, that's always going to be a positive number times sine of 5 pi over 4, that's in the third quadrant, that's a negative 1 over radical 2. So that is a negative number, which means I'm further to the left after 5 pi on 4. So therefore, farthest left at t equals 5 pi over 4. Conveniently, I don't need to find the exact position because I don't really know it, but I know that it's further to the left here after 5 pi over 4 than it was at 0. So that's the first part of this problem. Now, you can notice that this is only a part A and B because both parts A and B require so much work. Part B, find the constant A for which, let's see here, A x double prime plus x prime plus x of t is equal to 0. So I need to find A so that all of that is satisfied. I already know what the original function is, and I already have the derivative because that's my velocity equation. So I'm okay there. What I need to find is my second derivative. So let's see here. X of t is e to the negative t sine t. X prime of t, which is velocity from earlier, is e to the negative t cosine t minus e to the negative t sine t. Now I need x double prime, so I need to do product rule twice here. So I've got e to the negative t times the derivative of cosine is negative sine t plus cosine t times negative e to the negative t. So that's the product rule for just that part. Now minus, watch out for your negatives, e to the negative t times the derivative of sine is cosine t plus sine t times the antiderivative of e to the negative t is negative e to the negative t, but I also have this negative here. That ends up as a positive e to the negative t. So when I look at all this, I've got, this is still x double prime, negative e to the negative t sine t minus e to the negative t cosine t minus e to the negative t cosine t plus e to the negative t sine t. It looks like a mess, but look at how much stuff cancels out. I have a negative e to the negative t sine t, and I have a positive e to the negative t sine t. Those cancel out, and then right here, those are like terms. They're both e to the negative t's and cosines. So x double prime of t is equal to negative 2 e to the negative t cosine t. So now I have to fill in my formula. A times negative 2 e to the negative t cosine t plus x prime, which is all of this up here. So plus e to the negative t cosine t minus e to the negative t sine t plus the original function, e to the negative t sine t is equal to 0. So what I want you to realize, what I have here is a times, this is x double prime, all of this is x prime, and then this on the end is just x. So this is what I have. I need to solve this. Oh, nice, sweet. Look at right here. I've got some stuff that cancels out. I have a negative e to the negative t sine t and a positive e. Those cancel out. Now what I can do is I can take this whole thing right here and add it to the other side. So I have this left over here. E to the negative t cosine t is equal to a positive 2a e to the negative t cosine t. Now if you'll notice, let's divide by e to the negative t cosine t, e to the negative t cosine t, and I end up with 1 equals, all of this is canceling, 2a, a is equal to 1/2, and you are done. A lot of work for a simple answer.